Okay, we are on lesson 11.1.2. Before we start, you need to locate your resource pages. So it's highlighted right here, 11.1.2 resource pages. There are 4 pages, and it is the net of 4 different pyramids. It was labeled A, B, C, and D, as you can see in the picture here. Okay, so once you have located your resource pages, make sure to cut them out around the edges and fold along so that you can have the faces all facing out, like you are seeing in this next picture. In the video next, you are going to see how they are put together into a 3-dimensional shape. So fold along the edges and glue the tabs together, and you're going to see that in a very quick video next. Okay, so we now have our pyramids, right? We have our pyramid A, pyramid B, pyramid C. My pyramid C is a little bit coming apart, but it's okay. So this is my pyramid C and pyramid D. Right? I know these are different colors than the ones in the video, but as yours is probably going to be a different color than mine because we printed them on whatever cardstock we have. Okay, all right, we're ready for this. So a pyramid is a polyhedron with a polygonal base. So polygon base formed by connecting each point of the base to a single point given, the apex. So that's up here. This is your apex, right? So every single pyramid you have has an apex, a tip right here. And this one, even though it's slanted, is up here, right here. Here's the apex, all right? So each triangular lateral face of a pyramid is formed by the segment formed from the apex to the endpoint of a side of the base and the side itself. All right, so yes, I found a typo. This is from, not form, right? A tetrahedron is a special pyramid because any face can act as its own base. So a tetrahedron is because every single face is the same. So this one is very special, right? So you built the 4 solids, which you already did. Now you're gonna sketch each pyramid in the table to the right. What is same about each pyramid? What is different? So what is same about each pyramid? What is different? Well, first things first, let's start with the first pyramid. Pyramid A has a triangular base. So we briefly did this in the homework before, so we're going to try this again. You have a triangular base, and it's actually easier to just kind of draw them so it's not super perfect. And then you want to draw the tip kind of off to the side so you can use that to connect all of your sides. Oops. All right, let's try this again. I think I can do better if I have really straight lines, so let's try again. So I'm going to have a triangle. And again, it is really an equilateral triangle, but I'm doing this on purpose so that it's not going to look perfect. I put my point here. So you're going to have one here, have one here, and have one here. There's your pyramid, right? This is a tetrahedron or a triangular pyramid. You name the pyramid by naming the base, right? So the base is a pyramid, a triangle, so it's a triangular pyramid. Okay, what is its surface area? Well, we'll talk about it in a minute because we got to use our ruler to measure this out and figure out the surface area of our pyramid, right? All right, pyramid B has a square bottom. So the easiest way is to draw that square as a parallelogram or a rhombus, okay? So you want to do that as a parallelogram or a rhombus, and then put the tip up here, and you can connect, and lastly connect. There's your pyramid. So this is a square pyramid because you have a square on the bottom. Okay, next one is also a square pyramid. You have a square on the bottom, but it's tilted to one side. So we're going to try to see if we can draw that better. So again, we start with a rhombus. right? And then your tip is actually on the side here. So you start with the tip and go here, here, and connect everything, every single side. So it's a little tilted. So this is going to be an oblique square pyramid. Oblique means it's tilted to one side. So oblique square pyramid. The last one is hard. This one has a hexagon on the bottom, so it's a hexagonal pyramid. So we're going to try our best, right? So I think the easiest way is to, again, draw your hexagon a little bit flat. So here's my hexagon. And then put the tip here and start connecting your tip to all the different edges of this beautiful pyramid. There you go. So this is a hexagonal pyramid. All right, so it says we're going to find the surface area, right? And you're going to use rulers to find the dimension of the edges in centimeters. Okay, so pyramid A, we're going to use my ruler to find the fact that each triangle, so take, I think it's easiest in centimeters. If you use inches, it's going to be a little bit bigger. So I like metrics. So take your ruler, go with the centimeter, and it looks like my base is 7.4 centimeters, and my height is, oh, I cannot see, 7.4. This one is, sorry, it's very hard to see on my 6.4. All right, so my base is 7.4 and this is 6.4. So there's 4 of these. So 4 times 1/2 base of 7.4, height of 6.4. Okay, and my handy dandy calculator is going to help me out here and go 4 times 1/2 times 7.4 times 6.4 gives me a surface area of 94.72 square centimeters. Okay, all right, for the square pyramid, I have a square on the bottom and I have 4 triangles. So I'm gonna figure out the 4 triangles first. So 4 times 1/2. Okay, what is my base here? So take my ruler, measure out my base. My base is 5.5. So 5.5, and that's also the side of my square. So I'm gonna take that and add it to 5.5 squared, because that's the base, right? And then the height, remember the height is this line right here on your triangle side. So the one that has a little right angle there. So the height is about 6.2. Okay, so what would that give me? That would give me 4 times 1/2 times, times 5.5 times 6.2. So that part is 60, I'm going to use this space here, 68.2 plus 5.5 squared. That gives me 30.25. So a total of 98.45 square centimeters. Okay. All right. This triangle here. Okay. So this triangle, this oblique triangle, let's see. So it is a right angle on one side, right angle on the other side. And then it's right angle on every side. It's just a little bit lopsided, but this is beautiful. All right. So I think these two are the same, but let's check. So the 2 big triangles look the same and the 2 little triangles look the same, but let's see. So little triangles, the base is 5.6. The base is 5.6 and the height is 5.5. And then the other little right triangle on the side is also, yep, 5.6 by 5.5. So I have 2 triangles times 1/2 5.6 times 5.5, and I have two bigger right triangles on this side, the slant side, right? I have 2 bigger right triangles. So the base here is also 5.5, right? But then the height is a lot longer this time. This one is 7.9. All right, so plus 2 more, 1/2 5.5 times 7.9. And I have a square on the bottom that's 5.5 squared. Ooh, okay, so this one has a very different surface area than the other one. Okay, so that gives me Let's use my space here. 2 times 1/2, 5.6 times 5.5. Okay, that's 30.8. And then the other one is 43.45. And then we had the 5.5 squared from the other one, 30.25. So that is a total of, let's see, 30.8. We get a total of 104.5 square centimeters. Right? Last one, the hexagonal surface area, hexagonal pyramid. So the hexagonal pyramid has 6 triangles around because it's a hexagon. So 6 times 1/2. And now I need to figure out the base. The base, again, we're using this triangle right here, the one with the line here and this right angled height. All right, so the base of this is going to be 3.6. And then the height is 0 all the way there. That is about 5.4. And then we gotta add the hexagon on the bottom. So remind ourselves how to find the hexagon, right? So again, using whatever room I have here to help me, I'm gonna zoom in so you can see what I'm doing here. So remember our hexagon, the side is 3.6. To figure that out, we need the height here, right? And we like this because this is a 30, 60, 90 triangle. So that means that triangle I'm looking at here, this is 60 degrees, that's 90. So that's 1.8 because it's half. So this height is 1.8 root 3. So this triangle is 1/2 base times height. Okay, so that's a lot of things to multiply out. So let's see. I got my root 3 times 1.8 times 3.6 times 1/2. So each triangle is 5.61, right? And this is a hexagon, so there's 6 of them. So area is 6 times 5.61 to get 33.67. So 33.67, that's the area of that hexagon on the bottom, okay? All right, so let's multiply this whole thing out. I get 6 times 1/2 times 3.6 times 5.4. That's 58.32 plus a 33.67. I get 91.99 square centimeters for my hexagonal pyramid. Okay, all right, that's a lot of calculation. Well, the calculator did most of the work for us. Okay, so use a ruler. We already did that. So we're on the last one. Compare pyramids B and C. So here's pyramid B and here's pyramid C. Which do you think has more volume? So, well, the thing is, the pyramids have the same base, right? So if you take 2 pyramids, put them together, you'll see the bases are exactly the same, so they match up. So bases are the same. Now I need to know the height, the true height. True height means it's hard to see, but it goes from the middle of the base all the way to the tip. Now, if we line them up, you will see that pyramid C is actually a little bit taller. Now, it's a little slanted, but it's a little bit taller than pyramid B, right? Again, my hands aren't flat, but if I put it on a ruler, you will see that pyramid C is taller. So because it has a higher height, it should have a bigger volume because the bases are exactly the same. So I would say C has a bigger height. They have the same base. So C has more volume. Okay, and of course you can check it out, but that's it. All right, and then last one here. So it says the Trans-America building in San Francisco is built of concrete and is shaped like a square base pyramid. Okay, so that's the first thing we want to draw a picture. So it looks like a square base pyramid. Remember, square base pyramid means you start off kind of like a rhombus. That's how you can see everything. Okay. All right, got my pyramid here. Okay, so building is periodically power washed using 1 gallon clean solution for every 250 square meters of surface. So 1 gallon for 250 square meters. Okay, as a new building manager, you need to order the cleaning supplies for this large task. The problem is that you do not know the height of each triangular face of the building. You only know the vertical height of the building from the base to the top vertex. All right, so determine the amount of cleaning solution needed to wash the Trans-American building if the edge of the square base is 96 meters. So the edge is 96 meters. And the height of the building is 220 meters. So be careful. The height of the building, like I said before, it's the tip all the way to the middle of the base there. That's the height of the building. That's your 90 degrees. So that is 220 meters. Okay. So in order to figure out the surface that we're going to have to clean, you want the height of the triangle. So you want what we call the slant height. You want this height right here. Now, notice what I'm drawing here. If I continue that idea, I can go ahead and continue this. Notice that is a right triangle, and that's always true in these square pyramids. So you can use that idea to help you figure out what the height is. Because what do we know of this triangle? So let's try to draw this out. What do we know of this triangle? Well, we know that this triangle has 220 on this side, and this base is not 96, it's halfway of it. So it's really 48 meters. So now we can figure out this height by using Pythagorean theorem. So 48 squared plus 220 squared equals height squared. Okay, so 48 squared, again, my handy dandy calculator is going to help me. 48 squared is 2,304. 220 squared is 48,400. So that's 5,704. So my height is about 225.18 meters. Okay, now that's great. That's going to help me figure out how much surface I'm going to clean. Well, when they say surface in this case, we're ignoring the base because you're not going to clean the base. The base is where we're stepping on. So we're only looking at the 4 triangles around. So the surface area is going to be 4 times 1/2 base of 96 times the height you just got, which is 225.18. All right. So how much am I cleaning? So that's 4 times 1/2 times 96 times 225.18. So you are cleaning, wow, 43,234.56 square meters. Now, how much cleaning solution do you need? Well, you got to take that and now divide it by 250 because every 250 is 1 gallon, right? So divided by 250. That would give me 172.9. Now you got to round up because you got to clean more than clean less, right? So it's really 173 gallons of solution. Okay, that was a cool problem. All right, that's it, guys.